Okay, we're in section 131 of the notes. Very consistently told story. There's going to be contents, examples for you to concentrate on, and then exercises for you to work through. All right, this is a draft version of Ron Bannon's, or my version of Webster Wells' Advanced Course in Algebra. That's based at 1904. The PDF document is only being made available now to the Prison Mathematics Project participants. All right. In the future, this document will be published, and for the students and teachers out there that want to get a copy of this thing, what I recommend you do now is just email me. My email address is Bannon, that's B as in boy, the @ symbol, NNON.US. All right? All right, so we're gonna kind of plow forward here, and we're certainly getting closer and closer to the end of the course. Now, these are going to be solutions of higher equations, commensurable roots. All right, I'm going to say really boils down to what's called the rational root theorem. All right, so I'm going to tell you rational numbers here are going to be a ratio of integers, and these are going to be polynomials with integer coefficients. All right, it's a lot to read though, I know that, and I'll start talking through this. Now in the beginning, I kind of like try to summarize the rational root theorem. And again, we have a polynomial of this form over here, integer coefficients. And then it goes on to say every rational zero of x has this form over here. All right? So it's something to do with the factors of this guy here and this guy over here. And I would basically boil this down to what's called trial and error, which is really something we started with a really long time ago. Now, the problem with trial and error is it can be frustrating, especially if you try things and it's never going to work. So what I want to do is I kind of want to look at this problem over here, and I know they say commensurable roots. So I'm looking for what's called a rational root, and that's a ratio of integer. All right. So I'm gonna write this down in stages for you. So I'm gonna say f of x is a polynomial with integer coefficients, 4x cubed minus 12x squared plus 27x minus 19. And what I'm going to say is there's candidates for roots of this problem over here. And the candidates would be the factors of this divided by the factors of this. Now when I say that, it's plus or minus. So I'm going to list the candidate roots for you. So plus or minus. And the way I'm going to write this, I'm going to write down the factors of 19. It could be a 1 or a 19. And the factors of 4 could be 1, could be 2, and it could be 4. Now, a lot of people write down this way, and they just leave it that way. But I want to make sure you know this is a list of numbers. I'm going to write the list down. And the way I'm going to do the list, I'm just going to do one thing at a time. I'm going to divide by 1. What would you get? You get 1 and 19. Then I would divide by 2, and what would you get? You would get 1/2, and you get 19 halves. And then I would divide by 4. Right? What do you get when you divide by 4? You get a quarter, and you get 19 quarters. So the first thing I would do, I would just list them. Now certainly they're listed for you. I want to point out where that is. They're right over here. It's actually listed for you. All right? So I list them too. Now someone says, could I test all those? Of course you can. What I want to do is, I don't want to test everyone. I want to start looking around. Right? I want to do something easy. All right? I'm going to say, and again, I'm not saying it's productive, but maybe none of them work. It's possible. So I'm going to say over here, I'm going to look for one. And what's the easiest number in that list? I would say the number 1 is. Now, again, you might say this is wishful thinking, and it may be, but I'm going to see if it's a root. Now, if 1 is a root, right, if 1 is a root, I'm saying the factor would be x minus 1, and then there'd be something over here. But also I would say is f of 1 would give me 0 times whatever, which is 0. So what I'm saying, if it is a root, f of 1 would be 0. Well, let me write this down for you. And again, it's wishful thinking, I know that. What do you get? 4 minus 12, just plugging the 1 in, plus 27 minus 19. Now, if this doesn't work, the next thing I'll try is minus 1. Then I might go to 19, minus 19. You get the idea. I don't want to be here all day testing things out. I'm hoping I'm going to get something. What's 4 minus 12 minus 8? What's 27 minus 19? That's plus 8. Well, lo and behold, I now have a factor. All right? Why is that? I found out that x minus 1 is, in fact, a factor of that. All right? So what I'm going to do is I'm done, and I'm going to use this guy now. I know this guy works out pretty nicely. Right? I'm going to use him now. Let's put this down now. So the way I'm going to do it, I'm going to divide. Now, once I divide, you have to start to realize, what am I dividing? I'm dividing the polynomial by the factor. And again, if the root is 1, the factor would be x minus 1. And what do I know about this? It's going to go really nicely into it. There will be no remainder. Unless, of course, I make a mistake. So it's 4x cubed minus 12x squared plus 27x minus 19. Well, what times x would give you 4x cubed? That would be 4x squared. Minus 4x squared. I'm going to subtract. This is going to work nicely. What times that could give you minus 8x squared? That'd be minus 8x. What do you get there? Minus 8x squared. That's a match. Then you're going to get plus 8x. You're going to subtract. What do you get? 19x. Need to match again, plus 19. 19 times x is 19x, minus 19. As expected, remainder 0. So now I know this. I know 4x cubed minus 12x squared plus 27x minus 19 factors into x minus 1, 4x squared minus 8x plus 19. So here's the problem. I had this, which I felt was very difficult. I found this by trial and error, and now I'm left with this over here. This over here, the 4x squared minus 8x plus 19, is a depressed equation. I'm sorry, depressed polynomial. So I started cubic, I got quadratic now. And we have methods for doing quadratics, which is good. It made it essentially an easier problem for me. And I want to factor it, all right? Now, someone says, how would you factor that? I would say by trial and error again. Let me put this down for you. Remember, if things don't work, I'm not going to try too much, right? But if things don't work, I'll try it, right? What do you get? 4x squared minus 8x plus 19. Now, I'm going to say this doesn't look, doable to me. It seems like no matter what I would choose, like 4x, and then, 19 and 1, I just can't see it, like 19 and 1 or 1 and 19. It just doesn't look productive, right? But I do have a technique for factoring it. And what I'm going to do is I'm going to erase this over here, and I want to go through that technique for factoring it. So what do you get over here? 4x squared minus 8x plus 19 equals 0. Now, why are you choosing a 0? I'm interested in factoring it. I'm really interested in getting the factors, which would give me the zeros. Let's take a look. X will equal, I'll write this down for you, the minus the b, which is 8, this quadratic formula, plus or minus. You could also complete the square if you want. And let's see, that's b squared, which is 64. And don't worry, we have an answer key, we can check it. Minus 4, you get the idea? Times 4, that's the a, times the c, which is 19. Over twice a. What's twice a? It's 8. Let's keep going. I know this is tough. 8 plus or minus. I got an 8 in the bottom. I got a root here. I'll figure this out for you. And it's going to be 64 minus 16 times 19. Well, I got some work to do here, don't I? So 64 minus Well, let's see. Maybe I'll do something like 16 times 19. 9 times 6 is 54. 9 plus 5 is 14. And then you're going to get, 1 times 16. It's actually 10, by the way, so that's why it's 160. 4. 6 and 4 is going to be, did I do that right? 4, 10, 304. And what do you have over here? Let's see, that's minus 240. I'll write that down for you. All right, I'm going to get rid of my chicken scratch. I don't need to see that anymore. My baby arithmetic I don't see anymore either. But I got to do that minus 240, right? Now, I hope you remember this is going to be complex here. Get my eraser out. And I'll put this over here. So this will be 8 plus or minus I. What's frustrating, if you do make a mistake and you look at your answer key, you say that you have to do it again. But I'm being somewhat careful. 240, 2, 120, 2, 60, 2, 30, 2, and 15. So I'm going to say it's 4 root 15. I'm going to get my eraser out, get rid of my baby stuff. All right, I want to simplify that if I can. And I'm going to, I'm looking at it, and I'm going to, I really need to simplify it, by the way. And you may say, why is that? It just doesn't look right to me. So I'm going to divide by 4. 2, 2, plus or minus I root 15. All right, so someone says, where's this going? I want to claim I found all 3 roots now. So what are the roots are going to be? I'll write them down for you. The first root I found is x equals 1. What's the next root I found? I found the root x equals 2 plus I root 15 over 2. That doesn't look like a 15, does it? The other root I found is x equals 2 minus I root 15 over 2. Now certainly I want to look at the key, and I want to point out this thing is listed for you. All right, so I got that listed, and I got the other root of 1 listed as well. All right, what I want to do is I want to factor it though. And someone says like so much work to do that. I'm going to write down, what I'm looking for. And someone said, why do you want to do that? Well, I want to see if I can do it. So 4x cubed. Don't be intimidated. We have the answer key, and this is a good thing. I'll write this down. X minus 1. Again, I want to claim what I'm doing over here. I'm doing subtraction of the root. I did this one over here. Now, I'm going to write this down a little differently. And someone says, why is that? I need to subtract them. So I'll write this down. So it's x equals, 2 divided by 2 is 1, plus I root 15 over 2. And the other one is x equals 1 minus I root 15 over 2. I'm going to write those down for you now. So let me put the other factor down. It looks tough, but I'll write them down for you. So it's going to be x minus this guy. Now, I'm not saying this is right. I'm just saying I'm writing it down. Then we'll talk about what's right, what's wrong. All right, so it's going to be minus 1 minus I root 15 over 2 times, well, now we're going to put this one down. What's going to be x minus 1, and minus a minus is plus, I root 15 over 2. Now, by the way, this can't be right. I'll tell you the number one reason it can't be right. If you just simply multiplied out x, x, and x, you're not going to get this. So what do I need? I need a number 4. Now, I'm certainly I get that there, but certainly I'm going to take that 4, and I'm going to associate the 4 with these 2 terms. Oops, sorry about that. I didn't mean to do that. Let me go backwards. So I'm going to take that 4, and I'm going to erase it. And I'm going to put the 2 here and there. Let's do it. What do you get? You would get x minus 1. I'm going to do this guy now. You're going to get 2x minus 2 minus I root 15. And I'm going to associate a 2 with the other guy. That's 4, right? Let's keep going. What do you get? 2x minus 2 plus I root 15. All right. Let me tell you our goals here. Our goal is to get it to factor. I'm going to point out this is done for me. I'm going to tell you where it is. I'm going to look at it. I know it's tough, by the way. Whoops, I keep doing that. I know that. This is the factored form. Am I getting the same answer? Let's take a look. I get the x minus 1. I get the 2x minus 2 plus I root 15 and 2x minus 2. Yeah, looks like they're pretty good. And I get all 3 roots. All right, let's go to the next problem. All right, we're looking at it again, and what I'm going to do is I need to write down the candidate rational roots. All right, let me put this down for you. F of x, and this can get very tedious. Particularly if I copy wrong, right? So I'm going to list the candidate roots down for you. Right, so plus or minus. Let me go through this again with you. I need the factors of 6, and I'm going to divide by the factors of 1. Let's see if we can do that. What are the factors of 6? 1, 2, 3, and 6. What's the factors of 1? Just 1. A lot of people write down this way, but I'm going to actually write down plus or minus. Well, this looks pretty easy. 1, 2, 3, and 6. Again, wishful thinking doesn't always pay off, but I want to give it a try. All right, and some people are better at this than others, but I want to try it. So which number should I try first? Probably 1. I'm hoping it's going to be a 0. What would you get? 1 minus 7 plus 1 plus 6. Let's take a look. That's 0. That's set. Wow, worked again. So what do I now know? I know this. I know that f of x has a factor. And again, the root's 1, so the factor would be x minus 1. But you know what? If I do the division, I'd get a cubic. And I'd be back in the same loop, trying to figure it out. So what I want to do is I want to look around for another rational root. I'm not going to try 1 again. Now, what's the next number you might try? Let's try f of minus 1. Who knows? Maybe it'll work. You can get 1 plus 1 minus 7 plus 1 plus 6. Definitely doesn't work. Crossing it off. Let's try 2. F of 2. What do you get? More difficult though, right? Hey, I hope I don't have to go to 6. 2 to the 4th power, 2 times 2 is 4, 8, 16. Minus 8. Let's see, I'm trying 2, right? So it's going to be minus 7 times 4 is 28, right? Plus 2 plus 6. It's more challenging, isn't it? 8 minus 28 plus 8. Nah, that's not working either, is it? Let me erase that. Let me go to minus 2 now. And again, this is trial and error. What do you get over there? Let's see, 16 plus 8. Let's see, minus 28. Minus 2 plus 6. Well, let's see. 16 and 8 is 24, right? And 24 minus 28 is minus 4. And then I have minus 2 plus 6. Wow, that worked out beautifully. So I have another factor. What's that other factor going to be? X plus 2. I'm going to erase it. And you may wonder why I'm erasing. It's like my little baby work on the side. No one needs to see that. I did talk through it, though. Now I got to divide. And someone said, how would you divide that? Well, one thing I'd want to do is just expand this guy over here. Just expand it. Let's expand it out and see what you get. So if you expand that, what do you get? You would get x squared. Let's see, plus x minus 2. Now, what's nice about the division, it's going to be nice. And I'll put this down for you. So the division is going to be x squared plus x. Now, when I say it's going to be nice, provided I don't make any errors, it's going to be nice. If I'm making errors, it's not going to be nice. What do you mean by nice? 0 remainder. Let's repeat. What times x squared gives you x4? X squared. This is called a depressed quadratic now. I started with a 4th degree polynomial. I'm going to end up with a 2nd degree polynomial. What do you get over here? X4. Let's see. Looks like going to be x cubed, right? And then what do you get? Minus 2x squared. I'm going to subtract. And let's see, you get minus 2x cubed minus 5x squared plus x plus 6. Well, I'm going to do a match now. So it's going to be minus 2x. Minus 2x cubed minus 2x squared. And then you're going to get plus 4x. Well, I'm going to subtract. And what do you get there? Minus 3x squared. Let's see, minus 3x and plus 6. Got to repeat. Minus 3. What do you get? Minus 3x squared minus 3x plus 6. Lo and behold, you get a 0 remainder. So let me erase this over here. I'm done using that. And I'll write down the depressed quadratic now. And what's that depressed quadratic? It's the division. So it's going to be x squared minus 2x minus 3. And I think I'm ready to finish it off. X minus 1, x plus 2, x and x, 3 and 1, minus and plus. And by the way, they are in the list. I just didn't test them off. This is the factorization, and the roots are going to be as follows. The roots will be x equals 1, x equals minus 2. Whoops. We'll check the key later, by the way. Minus 2, x equals minus 1, and x equals 3. They're the roots. Let's check it. Wow, it's long, isn't it? And let's take a look. I got this, and I got this. Okay, I'm going to talk about the graph too. Now, I realize for a lot of students, they seem a tremendous amount of work down over here. You may have to look at the work. I'm not saying you do, by the way. Now, someone says, where'd the work come from? I did my chicken scratch on paper, and then I typed it up. All right? I typed it up. So I'm going to talk about the, again, I'm going to just get 1 minus 1 minus 2 and 3. What I'm going to do is talk about how to graph a polynomial by getting its roots. All right? Let's talk about this right now. So the polynomial that we're graphing is this guy over here. The first thing I would plot are the roots. 1, minus 1, minus 2. I'm plotting these things over here. And 3. The next thing I would do is I would put the y-intercept down. The y-intercept is when x is 0, what would you get? You would get 6. Fairly simple to do. Where's that? Right over here. The next thing I would do is I would look at the factored form, and I would perform sign analysis on it. Let me go through that with you. So what do we have? We have minus 2. That's one of the zeros. We have minus 1 is one of the zeros. We have 1 is another 0, and then 3 over here. Take test points. For example, what's a good test point between here? 0. Plug it in. If you plug in 0 in the factored form, what are you going to get? Negative positive, negative, positive. What would you get? Positive. So I know the connection between -1 and 1 has got to be positive, and it's got to go through this point over here. Now, what I don't know, though, I know it's positive, by the way. What I do not know is I don't know exactly how it connects together. So I'm going to point over here. Although I couldn't determine this at this stage of the game, I do know there's a connection between the two. And certainly I'm going to say a positive connection. Okay? But I'm not sure about where the relative maximum is. All right. Let me go to another location. I'm going to go to 2. That's between 3 and 2. And, certainly I want to talk about, what happens when you plug a 2 in. And again, we're using the factored form. That's all we're doing. So that would be plus 2 minus 3 is a negative number, right? And plus. What's it overall? Negative. Now, all I know is between 1 and 3, it has to be a negative. What I don't know is how low it goes. I have no idea how low it goes at this point. And this one over here is what's known as a relative. Actually, it's a global, but anyway, relative min. It's also global, by the way. Don't worry about those terms yet. All right, I'm going to go past the 3. I think you got some intuition about this. And take a test point like 4. What do you get? And again, I'm using the factored form. It would be plus, 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 plus. All I know is after the 3, it's going to be positive. All right? Let's go between -2 and -1. What's a good test point over here? I'll put this over here for you. I'd say -1.5. And what do you have to plug it in? Negative, 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 and a positive. What do you get overall? Negative. What do I know about this? The connection between -2 and -1 has got to be negative. What I don't know is this thing over here, which is the relative minimum. If you take a point after -2, I shouldn't say after, before, like -3, I put this over here. This is my test point. You get negative, 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 and negative. And negative times a negative times a negative times a negative is a positive. I know it's over here. Okay? Rough picture. It's a really rough picture. Now, someone says your graph is not rough. A machine did it. It did a whole bunch of points and connected the dots together. All right? So that's not too bad. Now, here's the problem. Someone says it's a tremendous amount of work to do that. It is. We want you to do the work, though. What does that mean? Well, after you study that section, read it, did the examples, have some understanding of what's been discussed, you need to start doing this. Like number 1. They gave you this thing over here. I'm really the same technique, by the way. All right? So, maybe I do some synthetic division here. I actually prefer this type of division over here to do that. I really do. What do? I also give you a picture. What do I do in the picture? I put the roots down for you. And I connect the dots together. I'm using a computer to do that. Oh, there's also a y-intercept down over here. And I do sign outs to connect the dots together. All right? So I do a bunch of examples. We would like you to try to do those examples. I show you different formats of division. I do not like synthetic division, but please do not share my biases. I prefer to do this. It actually looks better to me. Why is that? It reminds me of what I've done in grade school. I also give you a picture. All right? Same thing for number 3. Same thing for number 4. A lot of work, right? I know that. Number 5. Boy, 6. Hope there's not too many more. These are a lot. 7. 8. 9. You decide. 10. 11. The more you do, the better you get. I did them all too. I did every single problem by hand. 13. 14, and typed it up too. It even takes a lot more time, by the way. Not my entire education, but the later part of my education, things had to have been typed up. You couldn't have handed it in otherwise. 15, and that required knowledge of mathematical typesetting. 16, certainly if you're going to get into the publisher arena, they're not going to take your chicken scratch. You got to type it up. I guess that's the last problem, right? And that was number 16. That's 16 problems. Plenty of time, all right? What do we want you to do now? Sage. What's Sage? The computer algebra system, or a CAS. It's open source software, meaning it's free to download. You don't have to pay for it. You can contribute money to it though. They would like that. Interactive web-based application. And there's a bunch of code over here. All right. What I'm going to claim over here is I'm not really that interested in Sage at this point. I'm interested in doing what Sage I'm sorry, not Sage, but what Wells would want you to do is do things by hand. And you're going to learn a lot by that. But if you see any errors in my work, and I can almost guarantee there are errors, please reach out to me. I think you probably know my email address by now. Bannon, B as in boy, the @ symbol, nnon.us. And so you see an error, let me know you see an error. Or tell me where you found it. Say it was in section 131, example number 7, or section 131, exercise number 4. All right, I'll look at it. Please try to be clear though when you do it though. Thank you for paying attention.